So the second story is around, it's a much, much smaller scale. This was more kind of a fun little project that we did with the Columbia Land Trust. If folks aren't familiar, the Columbia Land Trust is one of the larger land trusts in the country. To date, they've conserved over 32,000 acres of land in Oregon and Washington. And one of the many things that they do is manage their lands for invasive species. And in their neck of the woods, one of the nastier ones is reed canary grass. And after hearing about our ability to acquire high resolution imagery using UASs, or unmanned aerial systems, or what the rest of us often call drones, we just like to say drones for good. Once they heard about our ability to do that and then do some post-flight image processing in order to automatically generate metrics, they called us up. And the project was to see how effective this technology would be to automatically detecting the extent of reed canary grass, both in the dormant season and in its more at the height of its growth. And so that's what we did. There was two sites, both one about 250 acres and one about 300 acres in the Columbia River estuary, about 30 river miles up from the mouth. And one of the challenges with this project or these sites is that they're tidal wetlands, and so it's pretty hard to get crews in there in boats and to do your traditional stick and tape measurements and transects. And so we went out there and flew the sites in a day. And in the bottom left, you can see the control area where it was not treated, and then on the right, the segmented the treatment the area or the site that's been treated. And it's a little bit hard to see at this scale, but you see the pink areas are areas where there's been treatment, and then the yellow is kind of a computer applied areas or interstitial regions that the image processing software detected after the fact. And so that's really the raw materials for us to help measure the interstitial areas and to do metric calculations after the fact. So the result was that that we generated a 1.6 gigabyte orthomosaic of these sites. That's the first picture there. That's just one little segment of the picture. We've crashed a few computers just trying to get them to display an image of that size and that resolution, but you're getting down to 2.5 centimeters. And because it's all georeferenced and orthorectified, you can do pretty precise measurements off of that image. One of the other outputs is the middle picture there is a point cloud. This is a point cloud of I got the number here. Let's see, 233 million points in that point cloud. Maybe a little bit hard to see, but in the middle of it is a truck with its hatch open. So you can kind of see this is or an oblique view of the site, and can be very helpful for a wide range of metric generation and also for getting a really good baseline picture of your site, maybe right when you acquire it or before you start doing a lot of work on it. And then the nice thing about this technology is that because we use flight control software, you can refly the exact same site 6 months down the road, 12 months down the road, 5 years down the road, and the drone will actually follow the exact same path. And because the first site has generated, the first visit generated a local reference plane using a ground control and a real-time, an RTK device, you can reestablish that coordinate system, and your change detection and measurements across time can also be very precise. And the last is a digital surface model that is generated there's output from the flight as well. So the benefits of this tool that helped CLT kind of scale their baseline data in the small for these couple of sites and really more of a pilot was that we decreased their cost significantly. You know, it took a couple hours to fly each site versus walking and boating it in a couple days. It also completely eliminated data entry and transcription. Quality and confidence, of course, go way up when it's that automated and you have that level of precision that you just can't get by traditional data collection or monitoring methods. And then your metrics are also automatically generated. And then last, you've got this really high resolution asset to establish the baseline condition of an area. And then last, their capabilities to do change detection were kind of new capabilities for them. And to be honest, there's a whole range of ideas of how they might be able to use this information going forward. So I think that story is still being told. All right.
Yeah. What we have a question here basically about what software, if we know what software was used to generate these products. I believe it was Pix4D.
That's right. Yeah, there's a couple different packages that we use. Yeah, to be clear, Sitka's capabilities or smarts don't get into image processing, so we're using third-party tools to do that. I think Pix4D was the image processing software, and I can get more. I'd be happy to follow up with a little bit more details on the full stack that we use, the full technology stack we use for that. It wasn't something that I was directly involved with, but happy to follow up.